Okay, so in this video, we are going to start from the common coagulants that are generally used in the water treatment plant. So once again, we'll quickly revise what we have seen. So for the removal of colloidal impurities, we have to go for sedimentation aided with coagulation. Now these colloidal impurities have charges on them. So to remove those charges, we have to add one chemical. That chemical is called coagulant, and this process is called as coagulation. These are the mechanisms which are used in the destabilization. This destabilization occurs when the coagulant is added to the water. Now, what are the certain chemicals or certain coagulants that are generally used? So these are the name of the four coagulants. One more thing you should note here, that how much amount of coagulant should be added to the water. So that amount of coagulant that has to be added to the water is called as dose of coagulant, or we can say optimum dose of coagulant. We should know that the dose cannot be randomly given, that it should not be much higher and it should not be much lower also. If it is lower, then the colloidal impurities will not get removed. If it is higher, then it can lead to some other problems. So we have to give the optimum dose of coagulant, and the optimum dose of coagulant is given by a test which is called as jar test. Okay, so jar test will be discussed separately, but right now you can just write it down, that optimum dose of coagulant is given by a test which is called as jar test. Jar test. Okay, now so we'll start with the first coagulant, that is aluminium sulfate, or we'll write it as alum now. So it is also called as alum. So it is a universal coagulant. It is a universal coagulant. Almost at every places this is used. In Marathi we call it as turti. Okay, so coagulation with alum is economical. So if we use this, this is economical. So it is effective in pH range of 6.5 to 8.5. So in this range, this is effective. So write down, besides acting as a coagulant, it also removes color, odor and taste. Color, odor and taste. So there is one important point that you should write. It imparts NCH. So what is the full form of NCH? Non-carbonate hardness. So it imparts non-carbonate hardness, and due to this water becomes acidic. So these are the important points from this alum. Now we'll write the reactions and how the dose is given. So alum plus alkalinity gives non-carbonate hardness plus floc plus gas plus water. Okay, so you can see here the water should have certain amount of alkalinity present. So even write that point also. It requires alkalinity. That is, water should be alkaline. It requires alkalinity in water to produce flux. Now, so we'll write down here. So this alum is Al2SO4 thrice dot 18H2O plus 3Ca HCO3 2. This gives 3CaSO4 plus 2Al OH3 plus 6CO2 plus 18H2O. So this is the reaction. In this reaction, this is called as flux. So the flux are generated here. So the remaining equations I am just writing it here. So calcium bicarbonate gives calcium carbonate plus carbon dioxide plus water. Then calcium carbonate, it gives calcium oxide plus carbon dioxide. Now talking about the molecular weight. So the molecular weight of alum. So this is alum. Okay. So the molecular weight, if you calculate, it will be 666. Then molecular weight of 3CaCO3. Okay. So calcium carbonate, if you see, calcium carbonate weight is 100. So 3 into 100 is 300. Then molecular weight, so I am not writing it completely, you can just write it down. Molecular weight of calcium oxide, this is equal to 40 plus 16, that is 56. So these are all the molecular weights. Now write down these formulas. So alkalinity required, this is expressed in mg per liter of CaCO3. So alkalinity required is equal to 300 divided by 666 into dose of alum. So this is the first formula. Then second is alkalinity deficiency. So alkalinity deficiency is whatever is the alkalinity required minus alkalinity present. And the last is the dose of quicklime required. So what is this quicklime? Quicklime is nothing but calcium oxide. So what is the dose required in mg per liter? So this you can calculate by 56 by 100 into alkalinity deficiency. So these are the three important formulas from which the questions from alum are asked. Okay, so you may be asked to calculate the dose of alum, alkalinity required is given, or sometimes you have to calculate the alkalinity deficiency or the dose of quicklime required. So by using these three formulas we will be solving the questions from Alam. So the questions we will be taking in the remaining videos. Now we will only be covering the theoretical concepts. Now after the Alam, the second one is ferrous sulfate. Ferrous sulfate. This is also called as copperous. So it produces flock. It produces flocks when pH is greater than 8.5. It is cheaper. It is cheaper than alum. So the reaction that is present here is ferrous sulfate plus hydrated lime plus hydrated lime. This is giving non-carbonate hardness NCH plus flock plus water. So ferrous sulfate formula is FeSO4.7H2 plus hydrated lime means calcium hydroxide, and this will give us calcium sulfate plus FeOH3 plus 7H2. FeOH2, this is called as precipitate, and this precipitate is nothing but it is a flock. Now molecular weight MW of FeSO4.7H2. So it is 56 plus 32 plus 16 into 4 plus 7 into H2 is 18. So if you calculate it, it should be 278 molecular weight of ferrous sulfate. So in this you have only one formula, that is dose of lime required. Dose of lime required. So this is 56 divided by 278 into dose of copperous. Into dose of copperous. So the next one now is ferric sulphate. Okay, so ferric sulphate, or we can call it as ferric chloride also. So these both are nearly same only. So while studying we have given the name as ferric chloride, so we'll take, so their properties are nearly same. So ferric chloride. So the important point is it has no effect. It has no effect on color of water. So it is effective. It is effective in pH range of. So what is the effective pH range? Less than 6.5 and greater than 8.5. So it is effective in this range. Now ferric sulfate plus ferric chloride These together they are called as chlorinated copperous. Chlorinated copperous. So the reactions are 6FeSO4.7H2O plus 3Cl2 gives 2Fe2SO4 thrice plus 2FeCl3 plus 42H2. So the reactions in this are not much important. So the remaining equations I am not writing it. So if you want to study it in detail, you can mention it in the comment. I will give the more detailed explanation about ferric chloride. But whatever information is required at this level, the information I have given it here. Okay. So the ferric chloride is completed. Now the next one is sodium aluminate. This is the last one. Sodium aluminate. So the formula for this is Na2Al2O4. So it produces flocks at any pH. So we have seen that the alum produces flock in the range of 6.5 to 8.5. Then ferrous sulphate produces the flock in greater than 8.5. Ferric chloride produces the flock less than 6.5 and greater than 8.5. Whereas this sodium aluminate is an all-rounder, it produces flocks at any pH, that is, it is effective at any pH. It requires alkalinity, or we can say lime, to produce flock. So all the coagulants, they require certain alkalinity to produce the flock, and that dose of lime we have written the formula. Now the equation for this is Na2Al2O4 plus calcium bicarbonate. So this gives CaAl2O4. So this is a flock plus Na2CO3 plus CO2 plus H2. Okay. See the reactions from the alum, that is the first one that we have seen. So reactions from alum and ferrous sulphate, that are important. The other reactions, that is the reactions of ferric chloride and sodium aluminate, are not much important. So all the reactions I have given it to you, and all the important formulas are also given. The questions from this are mostly numerical based, that is we have to calculate the dose of lime. Okay, but if the question is asked from the conceptual point of view, then you should remember which of the following is more economical. Okay, so among the four coagulants, alum is the most economical, and okay, not alum, the most economical is the ferrous sulphate, that is cheaper than alum. However, the pH range is most important, that is which coagulant is effective in which pH range, that is dependent on the pH of water, it works properly. So we have seen that the last one, that is sodium aluminate, it is working in all pH, and the remaining pH I have given it to you. Okay, so with this, now the common coagulants topic is completed. You should also remember this important point, that optimum dose of coagulant is given by a jar test.